Okay, so you know how we were just talking about the Pythagorean theorem?
Yeah.
Well, guess what?
Yeah.
It's not just about, like, triangles on a chalkboard.
Oh, no, no, not at all.
This thing is, like, everywhere. Like, did you know that TV screens, to get those perfect rectangle shapes, they actually use this theorem?
It's pretty cool, right?
Yeah, it's mind-blowing. I mean, you learned this formula, A plus B, A boy is C, and congrats, by the way, for tackling that. But it's so much more than just an equation.
It's a foundation of so many things we see and use every single day. It's this amazing link between pure math and the real world. We see those right triangles everywhere, and knowing how their sides relate to each other is surprisingly powerful.
All right, so our source starts off with a pretty standard Pythagorean theorem problem. They give us that formula, the A plus B equals C partner. But can we, like, break that down a bit? Remind everyone what each part actually means?
Absolutely. First off, gotta remember, this only works for right-angled triangles, right? The ones with that perfect 90-degree corner.
Right.
So the A and B in the equation, those stand for the lengths of the two shorter sides of that triangle. Those are called the legs, the ones that form the right angle. The C is the length of the longest side, the one always directly across from the right angle, and that's called the hypotenuse.
Got it. So the legs are A and B, and the hypotenuse is C.
You got it.
Perfect. Now, in our source, they use an example with the numbers 6 and 8 for the lengths of A and B. Can you walk us through what happens next?
Okay, so here's where the Pythagorean theorem really gets to work. We take those numbers, 6 and 8, and we square each of them.
So we're basically multiplying each number by itself, right?
Exactly. So 6 times 6 gives us 36, and 8 times 8 equals 64. Then we add those two results together, 36 plus 64, and that gives us 100.
Okay, so that final number, 100, what does that represent?
That 100 is the hypotenuse squared, or C.
So it's not the actual length of the hypotenuse, it's the length squared.
Exactly.
So how do we go from that 100, the C, to figure out what C actually is, like the real length of the hypotenuse?
To get to the actual length, we need to find the square root of 100. And in this case, the square root of 100 is 10. So that tells us that the hypotenuse of that right triangle is 10 units long.
Okay, so I think I'm getting it, but it still feels kind of, I don't know, abstract.
Oh.
Can you give us, like, a real-world scenario where knowing this would actually be helpful? Like, why should anyone care about the Pythagorean theorem?
Oh, there are tons of examples. Think about it this way. Imagine you're at a park, and this park is shaped like a perfect rectangle.
Okay, got the park.
And you're standing at one corner and want to meet your friend who's all the way at the opposite corner. Now, you could walk along the two sides of the park, right?
Sure, you could go all the way down one side and then make a right turn and go all the way down the other side.
Exactly. But what if you wanted to take a shortcut? Just cut right across the grass diagonally.
So you're talking about cutting across the park from one corner to the opposite corner in a straight line.
Yep. And the Pythagorean theorem is what helps you figure out how long that shortcut would actually be.
So if I know the length and the width of the park, I can use the theorem to figure out the exact distance of that diagonal path.
Exactly. Let's say, for example, the park is 300 feet long and 400 feet wide. Those are our A and B. We plug them into the equation, A plus B equals C per A, say, and we get, well, first we have to square them. So that's 300 times 300, which is 90,000.
Whoa, big numbers.
And then 400 times 400 is 160,000.
So that's 90,000 plus 160,000.
Right, and that equals 250,000. And remember, that's CC tray, the length of our shortcut squared.
So to get the actual length, we need the square root again.
You got it. And the square root of 250,000 is 500, so your shortcut across the park is 500 feet long.
Way shorter than walking along the two sides.
Yeah.
I'm starting to see how handy this could be.
Right. It's not just about parks, though. This theorem pops up everywhere.
Yeah, I was just thinking about that. Like, I bet builders use this all the time.
Oh, absolutely. Construction, engineering, navigation, they all rely on it.
So, like, if you're building a house and want to make sure the walls are perfectly straight and at right angles, you could use this to check.
Precisely. Or if you're building a bridge and need to figure out the lengths of support beams, Pythagorean theorem.
Wow, I never realized how much this one concept was involved in building things.
Even things like GPS systems, they use the Pythagorean theorem to calculate distances between points. It's everywhere.
Okay, so for everyone out there who's just starting to wrap their heads around the Pythagorean theorem, we've got a little challenge for you.
Oh, this is the fun part.
5 questions to get those math brains working.
Hit us with them.
All right, first one. If A is 3 and B is 4, what is C? Remember, A and B are the lengths of the legs of a right triangle, and C is the hypotenuse.
Your classic example.
Okay, number 2. Can you use the Pythagorean theorem on a triangle that doesn't have a right angle? Why or why not?
Oh, good one.
All right, number 3. Besides cutting across a park, what other real-life situations can you think of where knowing the Pythagorean theorem would be helpful? Get creative.
I can't wait to hear the answers to this one.
Okay, number 4. If you already know the lengths of all 3 sides of a triangle, can you use the theorem to figure out if it actually is a right triangle?
Ah, working it in reverse.
Last but not least, number 5. What happens to the length of the hypotenuse, that's C, if you keep one leg, let's say A, the same length, but you increase the length of the other leg, B? Does the hypotenuse get shorter, longer, or stay the same?
Visualize those
We
triangles.
hope those questions spark some fun conversations and maybe even a little friendly debate.
The Pythagorean theorem, it's not just a formula. It's a key that unlocks a deeper understanding of geometry, and it's got these real-world applications that might surprise you.
And there you have it, your deep dive into the Pythagorean theorem. We hope you walked away with a little more appreciation for how cool and actually useful math can be.
It's all around us.
Until next time.
See ya.